Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cindy.
And in studio with us we have Maddie. And Maddie, if somebody needed to contact us, what would they need to do?
For math homework, help call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So do you have all that social media stuff?
Some of it.
So what do you have?
I have YouTube. That's it.
So you look at YouTube and check stuff out every once in a while?
All the time.
Or do you have your own YouTube channel, I think is what it would be, right?
I want to, but I don't.
Well, guess what? You're going to be YouTube famous
Yay.
later on tonight, all right? So where do you go to school and what grade are you in?
I go to Kendrick Elementary School, and I'm in 5th grade.
How is 5th grade?
Good.
What's so good about it?
Everything.
Give me one thing.
It's fun.
Go. What's so fun about it?
The learning part.
Learning what?
Math.
Such as?
Volume.
So you like doing volume. So this is something that you've recently done then?
Kind of.
Kind of. What is something that you've done in math that you feel like it's never going to be a problem again? You've got it and you're good with it.
Multiplication?
So you're pretty good at multiplying.
Yes.
Good. Well, you're going to need to know that in order to do volume.
Yes.
So what do you know about volume right now?
I know that volume equals length times width times height.
And that's if you're doing something like a prism, correct?
Yes.
Would everything be the same if you were doing a cylinder? Do you know what that is?
Like a tall circle kind of?
Yeah, you're on the right track. I'm just asking in case there's something different maybe. I don't know. I mean, we'll check that out, okay? All right. So, you've been at Kendrick for a long time?
Since 2nd grade.
Since 2nd grade. Are they the Eagles or Cougars? What are they?
Cougars.
Cougars. All right, I was close. All right, so Kendrick Cougars. I figured it had to be a K sound, so Kendrick Cougars. So, you're going to help me out with a problem right now. You ready?
Yes.
This is the social media problem of the day. So all that social media stuff that you read before, we have one of our producers put out a problem on social media, and this is one that was presented today. So remember I said you need to help me out with division. So what does that problem say?
It says 527 divided by 8.
So what's the first thing you would do with that?
So I would see what times 8 equals close to 52.
Good. And what times 8 is close to 52?
Well, I would cross out because 7 times 8 equals 56.
Good.
But then I think 8 times 6 is 48, so that's really close. So I would say 6.
So you would say 6. So looking at the options that we have there, A, B, C, and D, do you know what the answer is already?
Yes.
What?
C.
Why?
Because it starts with a 6 and none of the others do.
Right, so we can do this one pretty quickly without even having to actually do the whole problem.
Yes.
Now I've got another question for you because I'm feeling pretty good with you about C also. But it says R. There's R's in these things.
Yes.
Usually you don't see that. What does that mean?
It means remainder.
So how do we get that?
So if you can't do it equally, then you have to do the remainder.
Okay. So when you said 8 times 6 was 48, we would take away 48 from 52. What would be left?
Let's see here. 52, that would be 4.
Excellent. And I like the way you're doing that because you do whatever you need to in order to get to the answer, right?
Yes.
So we've got a 4, and then what do we do with the 7?
Then we bring it down.
Okay, so now we have 47.
Yes.
So what would 8 times what be close to 47?
5, because I know that 6 times 8 equals 48, like we mentioned earlier. Then it would have to be 5 equals 40.
Very good. And what would be left?
It would be 7.
And that's where we're getting our remainder 7
Yes.
from? All right, so let's take a look and see if we are indeed correct with answer C. There you go, nicely done. First problem all done. Feeling pretty good?
Yes,
This is pretty easy, isn't it?
very.
Well, just wait. Now that you said it's very easy, we're going to give you some other problems to work with. But first, let's take a look at today's Math in the News. So today's Math in the News has to deal with a topic that is coming up tomorrow. Do you know what tomorrow is?
Yes.
What is it?
Combining volumes.
It is combining volume tomorrow in your math class, correct?
Yes.
Well, that is excellent that you know what is coming up tomorrow. Do you know what else is happening tomorrow?
No.
All right, take a look at the screen that I've got right here. What is that?
Groundhog Day.
Have you ever heard of Groundhog Day?
Yes.
What do you know about Groundhog Day?
So I don't know where, but there's a special groundhog, and it comes out on Groundhog Day, and they celebrate it.
There you go. Well, that's a pretty succinct way of saying it. So the place they do this is in Punxsutawney. You say that? Punxsutawney.
Punxsutawney?
And that's in Pennsylvania.
Oh.
You know where Pennsylvania is?
In the United States of America?
Excellent. That is a good answer. It is in the United States of America. Do you think it's near California or on the other side of the country?
Other side.
Ooh, you're sharp. So you know a little bit of geography right there. So what they do is in Punxsutawney, Pennsylvania, they have this groundhog named Phil. All right, and they pull him out once a year. And do you know what the shadow, no shadow thing means?
I've learned about it before, but I forgot it.
So if he sees his shadow, it means we're going to have a little more winter, right? No shadow, spring's supposed to come a little earlier. Okay. Now this is a big deal to a lot of people in a lot of the country because in wintertime they have very cold temperatures and a lot of snow. Here in California, we don't have that, do we?
Yeah, we don't.
All right. So let's take a look at a little bit more about the history of Groundhog Day, right? So it's in Pennsylvania, right? The Dutch settlers came up with this, all right? Europeans that came over, and they needed to have candles needed for winter, so this is part of where they're figuring out how much more winter are we going to have, all right? So I figured let's take a look at the percentages of how successful Punxsutawney Phil is. So you said you wanted to learn a little bit about percentages today.
Yes.
Because you're going to be doing it in 5th grade, but you haven't done it yet.
Yes.
So here we've got from 2012 to 2021 what his correct predictions have been, all right? So he said, well, he saw his shadow, right? And the temperatures in February were cold, right? They were below what it should be and above the next month. So did Phil get it right? No, he didn't get it right because he said we were going to have more winter. Okay. Here, he said we were going to have a good spring, right? An early spring. So here we did have warmer temperatures, so that meant for an earlier spring, warmer temperatures. So that's why he gets the check mark. He's done it correctly. All right. So how many years do we have here? Let's count them.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay. Now, if you had all 10 correct, let's say you were doing 10 problems on a test, what would your percent be if you got them all right?
100%.
100%. Now, if you only had one wrong, do you know what it would be? It would be 9 out of 10,
90.
90%. Okay, so that's basically how this is working. So we can look over here. How many green checks does Phil have?
He has 4.
So he has 40% success rate. Do you think being correct 40% of the time is good or bad?
Bad.
Bad. Phil needs a little work, doesn't he?
Yeah.
Yeah, he needs to get a little better at his predicting right there as far as the shadow, no shadow. And keep in mind, this is just an animal.
Yeah.
And a whole myth and stuff like that, right? So you kind of just have a little bit of fun with it, right?
Yeah.
Here's another percentage thing for you, probability. If I had a coin, what are the two sides of the coin? Do you know what those are called?
Heads and tails.
Heads and tails, right? What's the probability that if I toss a coin, it's going to come up heads?
50%.
How do you know that? Why did you come up with 50%?
Because on one side it's heads and then the other side it's tails, and
There's only two outcomes, right?
yeah.
So you're able to get heads 1 out of 2 times, right? That's, you can only, you've got a half and half shot at getting it, right? So it's 50%, okay? So he has a 50% shot at getting it right every year also, right? It's either gonna be early spring or late, one or the other. And he's only right 40% of the time. So did you know that and so Punxsutawney Phil is pretty famous, right?
Yes.
You've heard of him in Groundhog's Day.
Yes.
Did you know that there's an animal locally just as famous
There is?
and twice as good as Phil? What would twice as good be if he's 40%?
80%.
This guy, even better. That's pretty good, isn't it? Let's take a look at who it is. Have you ever been to COM? Have you heard of COM?
Yes, my grandma used to work there.
Stop the business. Have you been there?
Pretty much all the time.
Did you ever help out all the time? Sometimes, because you were probably a little younger, right?
Yeah, I was
All
really
right.
young.
Do you remember what your grandma did there?
Yes, she would walk out and she would like hold the snakes for other people to like pet it, or with the tortoises, or
Oh, good.
Yeah.
So she was handling the animals and taking care of them and things like that, right? So would you handle the snake and hold it too?
yes,
You like that, huh?
Yeah.
Yeah, there you go. What
as
about
long
the,
as it's not poisonous. So
well, that's probably a wise choice right there, because I
Yes.
wouldn't do that either. So Cinnamon is one of the black bears at COM. And Cinnamon, what they do is they put the logo of the teams in the Super Bowl. Do you know what the Super Bowl is?
yes, it's I forgot what sport it is.
It's a
But
football game. All right. So every year, people like to bet on who's going to win the Super Bowl, right? And if there's only 2 choices, what do you think your shots are at getting it correct?
50%.
50%, okay? So Cinnamon, they put food in each of these containers. And whichever one Sid goes to first and eats, they're saying that's who he thinks is going to win the Super Bowl. Now, does he really have an idea of what's going on?
No, Cinnamon is just a bear.
Right, he's just a bear, okay?
Animals.
But when he goes and eats these things, he's been right 85% of the time.
Oh wow.
So do you think it would be a good bet to follow what Cinnamon does or Phil?
Cinnamon.
There you go. All right. You know what? You're learning quite a bit today on probability odds and stuff like that. And that is today's Math in the News. So we do have Groundhog Day coming up tomorrow. But keep in mind, our buddy Punxsutawney Phil, about a 40% success rate. Cinnamon, here at COM, 85%. So you, young lady, are getting ready to do a little bit of math. You've already told us a little bit about what volume is.
Yes.
And we're going to have you start doing some volume, but you're going to do it right after this.
Hello and welcome to the International Space Station. My name is Shane Kimbrough and I'm an astronaut living and working here 250 miles above the Earth. Today we're going to be learning about what a simple machine is and exploring the different ways we're using simple machines up here in low Earth orbit. A simple machine is an object that helps us to easily accomplish a task by changing the direction or amount of a force. There are 6 different types of simple machines: a screw, inclined plane, wedge, lever, wheel, and axle and pulley. When we combine 2 or more of these simple machines together, they are called compound machines. Let's dive into the purpose of each of these devices and how we are using them up here on the station. A screw is a simple machine that helps to fasten two objects together. Up here we use a variety of screws in order to keep our station intact, especially as we deal with microgravity causing objects to drift around. Here's an example of a screw that we may use on a spacewalk. Inclined planes are a broad range of simple machines that use an angled plane to accomplish different tasks. Down on Earth, you use inclined planes to move things easily. But here in microgravity, we don't need inclined planes to help us move objects. If you look closely at a screw, you will see that it is made up of a rod with an inclined plane that spirals around it. This inclined plane helps the screw to fasten to another object. Another simple machine using inclined planes to accomplish something is a wedge. A wedge consists of two inclined planes combined to split or separate objects. We often use wedges to cut objects here on the International Space Station. A wheel and axle is exactly what it sounds like. A wheel is attached to an axle, helping it to rotate and move easily without friction. We sometimes use wheels to help move items that we need to be able to travel without floating away. An example of this would be the wheels on our crew equipment and translation aid cart. It is attached to a track using wheel and axles for movement, so we are able to use it on our spacewalks without the possibility of it drifting off. I mentioned compound machines before, and our Advanced Resistive Exercise Device, or ARED, is a great example of that. It combines the simple machines, levers, and pulleys to help us maintain muscle and bone density in micro-G. Levers use a surface situated on a fulcrum, or pivoting point, to move an object. Pulleys are simple machines that use a wheel and axle to change the direction of an object. The pulleys inside ARED allow us to set the level of resistance for our workouts. Thank you for learning about simple machines with me today. Now I'm going to send you back to Earth to design a compound machine you think we could use up here on the International Space Station. See you next time.
Well, simple machines may be simple, but they are quite integral to every part of everyday life. Have you studied about simple machines at all in school yet?
I think I have.
You think you have. So do you remember hearing about the pulleys and levers and
Yes.
fulcrums and wheels and axles and things like that?
Yes.
All right, so if you know those simple machines, you can develop more compound machines. And if you're like, I don't remember kind of that stuff, just ask your teacher. Say, hey, can we do a little bit with some simple machines? And because they're fun to play around with and experiment and play with and see how everything works. You like doing that kind of stuff?
Yes.
Take things apart, kind of see how they work on the inside? Yes. All right, cool. You ready to do some work finally? You've just been kind of hanging out all day.
Yeah.
You ready? All right, over to the board, young lady. We're going to put this up on under the camera first, though. This is the problem that is in your math book. This is the homework problem you have. And you have where you have to find volume, but these aren't simple figures. They're rather complex.
Yes.
All right. And you said you know a little bit about volume, but you don't like these ones necessarily because you haven't worked with them yet, right?
Yeah.
So Cindy's going to help you, but you have to let her know how you would start and what you know already.
Okay.
All right, go to it.
So I would have to find the length times the width times the height.
Okay.
So I would have to find the length, the width, and the height.
Okay. So does this look like one basic rectangular prism?
No,
It looks like, what's it look like?
it looks like a bench.
Okay. So can you picture it as two rectangular prisms?
Yes.
Or could you split it out to make it look like two rectangular prisms?
You could either split it right here, or you could split it right there.
Yeah. So either
I'll
one.
choose that one.
Okay. So you're looking at like two side-by-side rectangular prisms. Okay. So now that you have it as two parts, what could we do with the volume to find the volume of the whole thing? What do you think?
I think since when I look up here, that's 3. So it's basically right here. So I would put a tiny 3. So
you're talking about for this piece right here?
Yeah.
Okay. Oops.
So I would have to find the length, the width, and the height.
Okay.
So once I find it, I would label it with the L, the W, or the H.
Okay, so you're going to find the volume for this side right now.
Yes.
Okay, go for it.
So I see a 9, and if you look at it, then it would probably be like straight back. So I would put that as the length.
Okay.
So I put an L.
Okay.
Then I would, well, we have this, which is the width, I
Okay.
believe.
Sounds
So
good.
I'll put the, whoops.
That's fine. We know what it is, right? Okay.
So now that's all left. That one thing that's left is the H, which is the height. So I would have to find the height, which is, if I look at it this way, if we just look at it, it looks just like a not a triangle, a rectangle.
Okay.
So this looks like the height over here.
Okay. Right, because this would be the same as that, right?
Yes.
All right, so you have your 3 numbers,
So we multiply them together, I believe.
and then that'll give us this side. Okay, go for
Yes. I'm just gonna label this A, and then I'm gonna label this B.
it. Okay. Sounds like a good idea.
Okay, so multiply it together. So I know that 9 times 3 is 27. So we do 27 times 3. 3 times 7 is 21. Then 3 times 2 is 6, plus 2 is 8. So for that, it would be, I think it's like that.
It is, yes.
Okay, good, I was correct.
So before you move on, I know you
Yes.
said that you think it's like that.
Yes,
Why?
because I'm not sure, because we haven't really
Well, then
glanced.
talk to Cindy about it, because we want to make sure you know why you're doing that. Okay?
Okay.
Okay, so do you know what volume represents?
Volume is it's the whole thing.
So it's like how many cubic
Yeah.
units
cubic
you can
units.
fit inside.
Yes.
And then this 3 is read as cubic inches. And so this just represents that. It's representing that you're filling it with cubes.
So if I did a model, this is what my teacher said to us. So if you took an empty tissue box and you filled it with little blocks, then that would be the volume.
Exactly. Yeah. And then those volumes those blocks are cubes, which makes that a 3. Yeah.
So
Okay, so
now,
let's do part B,
part B.
or box B, or prism B.
It's hard to look at it because I don't know
Okay,
what's
so let's,
connected.
if I go like that, does that help?
Yes. Okay, so this is a 3 over there, because 3 plus 3 is 6, of course. That'd be like that.
Okay.
Then it's kind of hard because I don't know.
Do
because
you get
it's
confused
slanted.
what might be length and what might be width?
I mean, sometimes when it's really big.
So let me ask you this. Could I take a box and say it's sitting like this, and then I turn it like this?
Yeah.
Is it the same box?
Well, it's the same box. but
Yeah.
you
Does
just
it have the
turn
same volume?
Yes.
Yeah. So it doesn't really matter which one you technically label as length or width. It's going to come out the same because it's representing the same amount of space.
Oh.
So if you get confused, like, I don't know which one looks like which, you just have to kind of pick.
Okay.
But I'd say, since we said this is height, we should say this is height.
Yeah.
Because that way it matches up with what you did before.
Do you think that I can't tell? Is this straight?
So this is, and then like that. It's like, like this is the top of a box, and this is the front facing you, kind of how this one was. This was the front, and this is the top.
Okay, I get it.
Yeah?
I get it now.
See it now?
I think. Okay, yeah, I think I got it now.
Okay.
So this would be the length, and then, no, it's the length. Because over there.
It'll work as the length. Well, this one was the length, and this was the height, which would be the same as this. It's okay.
Oh.
Put that. It doesn't. It comes out the same. Because, like you
Oh,
said,
yeah.
you could just turn it and
Yeah.
reshape it, and it still has
Because
the same
it's
volume.
multiplication, and
Commutative property.
but
what
definitely
that's
not for
called.
division or subtraction, but like.
Exactly.
So it would be 3 times 6 times 9. So I like to do, I think I'll do 3 times 6, that would be 18. Oh, I did. 19.
Oops. There you go.
All right, that's something. You combine numbers and letters there, I think. Just go ahead and erase it, Maddie, and start over again. There you go.
All right, so you did 3 times 6 is 18.
Then we do a 9. Okay, so 9 times 8 is 72. Then 9 times 1 is 9, of course. Then we add 7. I like to think of it that I subtract 1 from the 7, then I add it to the 9, then it would be 10. Then I add the 6, so it would be 16.
So you can do it in your head better, huh?
Yeah.
Yeah.
Oh.
All right. So now we have each piece. So what do you think we should do to get the volume of everything?
Add it.
Sounds like a good idea.
I have a question. Do I put the 3?
You
On
still
the-
keep it as 3 because it's still representing filling each one with cubes, which is a 3 label.
Oh, okay.
Well, that's a good question.
I like
What do you
that you
think it
asked
would have
that.
been if it wasn't a 3, if you weren't sure? What do you think you would have put?
I would have just put 243 inches.
But we need 3 to make
Yeah.
sure it's cubic inches. All right? Nicely done. Great problem right there. So what I'd like you to do is quickly take a look at something like this. Would this be something you could figure out the volume of?
Yes.
So you would just have to take this part, right? Kind of like up there, you had 2 prisms next to each other. This one doesn't go all the way over like this, but it's still kind of the same thing that you're doing, right?
Yeah.
I've got a question before you start the next one. Is there a way, do you see how that section is taken out above A? Like it's removed?
Yes.
Like think about this, like this open area, right? Do you think if I could just take the whole solid and take this away, I would get the same answer?
So if you just took it apart?
If I filled this in, let's say, right, and I just said the volume of this whole thing, and then took this away, because what you're doing is you're doing the volume of 2 separate pieces and adding them together. What I want to know is, do you think I could take the volume of the whole thing, if this was filled in, and then take away this part? Do you think that might work?
Well, I don't think that it would be because because there's basically 2 of those that box on top, and then there's some over here.
Okay, so that's the way we're going to keep doing it. All right, that's the way you like it, that's the way you understand it, and that's the way we're going to do it. So let's go to the next problem right now. And you did some excellent work on that. So what do you think of this one?
Lots of numbers.
You think you can handle that one?
Yes.
Go to it.
Okay. So
So this is like a big rectangular prism with a little one on top.
yeah. So I'll just say it's a box right there and then a box right here. So like
Okay.
that. I'll split it apart. Okay, I'm just gonna erase that because. Okay, So I would split the little cube on top of this, the rectangle,
Prism.
the rectangular prism, and then I'll save the little one for later.
Okay.
So I look at it. So that's the width. Then so it's just basically 5 times 3, which is 15, because 15 times 1, it's same, 15. So put 15. Oh, it's different. I'm just gonna put inches.
Okay.
Okay. So then I look up there. It's a cube, so all of the sides are the same. So it'd be 2 on each side.
Right.
So it would just be 2 times 2 times 2. So I write it up here. Times. So I know that 2 times 2 is 4. So I'll put a 4 down. Times 2 equals 8. So I would put 8. Then I would have to add it up again. So 15 plus 8. So that would be, I just take 1 away and I'll save it for later. 4 plus 8 is 12. Then I add it back, which is 13. Oh, what happened?
It's okay. You moved it. That's all right.
I fixed it.
Got like a little hocus pocus on that screen right there. I'm making it do all sorts of stuff. So nicely done. So you're feeling pretty good about 23 cubic feet.
Yes.
What do you think, Cindy?
Looks good.
All right, nicely done right there. I especially appreciate how you, without having Cindy have to tell you, to put the units on there also, because a lot of students will just leave 23 and it'll be marked wrong.
Yes.
Some will even put 23 feet, and guess what it is?
Wrong.
Wrong. It's got to be 23 feet to the 3rd power, or cubed. Now 23, it's funny you bring that up because it's the year 2023, the year of Donnie. Do you know who Donnie is?
No.
Oh, a lot of people don't, but for some of the adults out there know Don Mattingly, number 23. So it's just funny that it came out to be number 23 right there. Have you ever been to Chick-fil-A?
Yes, I live next to it.
You live next to it?
Yes.
I wish I lived next to it, then I could go to it all the time. Well, for doing some great work so far, you've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. What's your favorite thing over there?
Probably the ice cream. I love the ice cream because it tastes like homemade ice cream, and I love homemade ice cream. It tastes different than regular ice cream.
You make your own homemade ice cream?
I've done it before.
You've done it before, and you like the homemade ice cream?
Yes.
Is there a particular flavor you make all the time?
Vanilla.
Vanilla, and I'm sure that's what you get at Chick-fil-A.
Yes.
Well, guess what? When you go, tell Troy to throw an ice cream cone on there for you too, all right? All right, hey, you know what? We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Until 5:30 in the afternoon, we'll be back with more right after this.
Hello, my name is Megan MacArthur.
And my name is Shane Kimbrough. We are living and working aboard the International Space Station orbiting 250 miles above your head. Here on station, we live in a microgravity environment which allows us to experiment with weightlessness and push the boundaries of science.
Today, we will demonstrate moment of inertia by first using a large flashlight, then demonstrating it with the human body. Are you ready? Let's go check it out. Inertia is the tendency of an object to resist change in its current state of motion. That might sound familiar since Newton's first law of motion is also referred to as the law of inertia. Moment of inertia, on the other hand, describes an object's tendency to resist rotational acceleration. An object's moment of inertia is a property that depends on how mass is distributed around its axis of rotation. There is a relationship between an object's mass distribution and how easily it spins or resists spinning. In general, objects have a lower moment of inertia and are easier to spin if the mass is closer to the axis of rotation. As you can see, the flashlight rotating about its longer axis is spinning at a faster rate than the flashlight rotating about its shorter axis. This is because its mass is closer to the axis of rotation. The spinning flashlight in this position has a lower moment of inertia, which means there is less resistance to rotation. When the flashlight is spun about its shorter axis, its mass is spread further away from the axis of rotation. In this position, the flashlight has a higher moment of inertia. Now let's see if this applies to humans as well.
Notice how fast Megan is spinning in relation to her body's position. When her arms are tucked in tightly next to her body, her moment of inertia decreases, which causes her to spin faster. When her arms are extended out, more mass is pulled further away from the axis of rotation, which increases her moment of inertia and causes her to spin slower. This happens because redistributing our mass changes our moment of inertia, which in turn changes how fast we spin. Thanks for coming aboard and watching our STEMonstration today. To explore more on moment of inertia, check out the Classroom Connection lesson that goes along with this video and discover many other lessons and activities at the STEM on Station website. See you next time.
Those guys are a nice little play on words with their STEM on Station and STEMonstrations and sing things like that. So, do you think you would ever like to go to outer space?
Yes.
Why?
Because I think it would be fun.
You think it'd be fun?
Yeah.
What would you like to do in outer space?
So if I was in the
Space station?
spaceship, I would bounce around.
You'd bounce around like a bounce house and stuff like that?
Yeah. And when I was little,
What do you mean when you were little? You think you're like an old lady now or something?
no, well, when I was like 2 or something.
Okay, when you were younger.
So I wished I want to fly to the moon, and then I remember it since.
So you remember that?
Yes.
So this is something you've wanted to do for a long time?
Yes.
And how old are you now?
11.
You're 11 years old.
Yes.
So I would say that within your lifetime, there's probably going to be a lot of people and a lot more travel to the moon. What do you think?
Yes.
Is this something that you think you might want to pursue later on when you get a little older?
Yeah.
All right, well, guess what? Before you do that, I have some other math problems for you to do. You ready?
Okay.
All right, back over to the board. You and Cindy are going to work on another one of these.
Okay. So split it up. Yeah. Yes, that's how you do it. Okay. So so this is the width. This is the height. No, I did it wrong. This is the length,
Okay.
and that's the height.
So let me ask you this before you go on. See how you drew your line right here?
Yes.
So if we use this as the height, that's really all of this, right?
Oh, yeah.
So we only want this much. So which number should we use instead?
2.
There you go.
Okay. Multiply. Oh, that was harsh. Okay. So 10 times 10 is 100. Times 2 is 200. Okay. So now we work on part A, and then this is B.
Okay.
Okay. So we go. Okay. So if that's 2, then we do 6 minus 2 equals 4,
Okay.
which is over there.
Which is over there, yeah.
So we would do this. This would be the height.
Okay.
Then this would be
Want me to
the,
help you out? You can reach it.
then, so that would be the height, that would be the length, then this would be the width.
Okay.
Okay, so we do, it can work either way, so I'll just do 10 times 3. So 10 times 3 is 30, then I take off the 0, like I'll put it in my pocket.
Okay.
And I'll do 4 times 3 is 12. Then I take the 0 out of my pocket and I stick it on the number, which is 120.
Nice job. I can't help but see a little face right here.
Wonderfully done. So explain a little bit about what you were thinking and how you were doing the calculations about this putting stuff in your pocket and stuff again.
Okay, so this is what I think. So I think like this. So I could just do 3 times 10 or 4 times 10. That would be like 40 or 30. Then I'll take the 0 in my pocket. Then I'll do 3 times 4 is 12. Then I stick it back on.
And that's a strategy that has worked for you for a long time.
Yes.
Do you remember when you learned to do that?
Didn't really learn it. I just did it.
You just did it.
Yeah.
Well, it doesn't matter when you learned it or when you did it, as long as you can still do it, right?
Yeah.
All right, nicely done. So erase the board. Do you feel as though you have a pretty good handle on doing these types of problems now?
Yes.
So when you start doing these in class later on this week, do you think you're going to be able to help out your teacher?
Yes.
Did you want to, I think you said you wanted to say hi. Did you want to say hi real quick to your teacher, whoever that is?
Hi, Miss McNallis. This is your student. You know me.
All right. Now, I know that before we went on, you said that you hadn't done anything with percents yet.
No.
Fractions, decimals, and percents are a big part of 5th grade. Okay. So what do you know about fractions right now?
A lot.
Such
Right.
as?
So, for example, 5 over 5 equals 1 whole. Then, it's really easy. You can divide, you can multiply, you can subtract, you can do addition. It's really easy. So for division, this is what my teacher calls it. She says, flip it and switch it. So we do, can you give me like 2 fractions? I just wanted to do an example.
So you want to divide these? Is this what you're doing?
Yes,
Okay.
dividing.
Because this is the only time your little switch it and flip it thing is going to work.
Okay, so I'm just gonna turn this into like a whole number.
Whoa, hold on, sister. You didn't tell us that.
Oh.
Leave it up there, 5 over 6.
Yeah, leave it there.
Yeah, we're going to go with this. We'll do your
Okay.
whole number later.
I'm just
Okay.
give you
okay.
some room there.
So we would flip it and switch it.
Okay.
So for this, we change it into 6 over 5. And then we switch it. Then we do multiplication. Then we can cross cancel. So that would be 1. That would be 2. So then that would be 2/5.
And there you go.
Do you know why you switch it and flip it?
So you can do it.
That's right, so you can do it. All right, so there's other ways
It's
to do
called a
it also.
reciprocal.
So maybe Cindy wants to talk to you, because you work with,
She just named it as reciprocal.
there you go.
That's impressive too.
All right, so you want the reciprocal.
Yes.
So because you do these with junior high students also.
Yes.
So what you're doing in 5th grade, guess when you're going to do it again?
We do it with negatives again in 7th grade.
Oh, wow.
And I bet you do it in 6th grade too.
And you'll do it in 8th grade.
Yep.
And you'll do it in 9th grade.
Every grade.
And then you'll keep
There you
using
go.
it, yes.
All right. So you know a little bit about fractions.
A lot.
A
Kind
lot.
of.
What about if I put 7 over 4? So explain that to me if you would. What do you need to do there?
You would have to, you would have to make it a mixed number.
All right. So show Cindy how to do that.
Okay, So So I know that 4 times 2 is 8. That's too big. So we just do equals 1, and then we do, 7 minus 4 equals 3. Then we do 3/4.
Okay.
You feeling pretty good about that?
Yes.
All right, so now what I'd like you to do is take the fraction and turn it into a decimal.
Yay. Okay. So I know that 4 times 25 is 100. Then we do 3 times 25. So 100, that's 75. So then that'll be 1.
All right, Slickster. So you went from fraction to decimal, now turn it into a percent.
I'm guessing?
Well, you're guessing that. I thought you knew this stuff.
Well, I don't know percentages.
Well, now you do, because you obviously know what you're doing, okay?
Oh, okay.
If you're taking a test, what's the highest score you can get?
100.
That's the whole thing, right?
Yes.
If you got them all right, if I have the whole thing, I have 100%. Well, how do you get 175% of something then?
Well, it would have to be 200%. Then you got some wrong on the math quiz. Then
Or what if there was a bonus questions?
yeah, bonus questions.
Oh, okay.
So you earn
have
extra.
Cindy work with you a little bit on the 1.75, what that means, and how that becomes 175% instead of bonus question. All right, so you girls take that over for a moment.
Okay, so that reads. So it's just one.
So do you know what
whole
percent means?
percent? So a percent is something like, for example, if I have a sphere, and if
I just mean just the words, percent.
Oh, percent. It's like a part of something.
Okay, and the word cent is a certain number.
100.
Yeah, because there's 100 years in a century and 100 cents in a dollar. So percent means something out of 100. So this part was already out of 100,
Yes.
right? Which is this part of it. And then you have this one whole,
Yes.
which is like you got the whole thing right. So that's representing what percent?
100%.
Yeah, so it's really like saying I have 100% and another 75%. So that's 175% altogether.
Or if you took 2 quizzes and you got 100% on this quiz and then a 75% on this quiz, then your teacher adds them
Just
together.
add the scores
Yeah.
together. Okay.
Just
All right,
think of it
so
like that.
Maddie, how old did you say you were?
I'm 11,
You're 11 years old, so you'll be how old next year?
12.
All right, clear the board. We're going to work with the number 12.
I remember.
So what I'd like you to do is I'd like you to write 12% up there. Now what I'd like you and Cindy to do is represent that as a decimal and a fraction, and if you can simplify it, do that also.
Okay, so I think put a 12 right there. Do a decimal.
Okay.
Okay, that's
And
the decimal.
why did you come up with that?
Because I remembered from the 1.75.
Okay.
Then I just did the opposite of what I did earlier.
Okay. And then what place value? How do you read this place value?
1200s.
Which is what percent means, right?
Yes.
So 12 out of 100.
So then it would be
1200s.
12 over 100, like I just
So
read.
same reasoning. Yeah.
Then we can simplify. Let's see here. Let's do 4 over 4.
And I'm just going to say, judging from all I've seen of you, you would never get a 12% on your math test.
No, never.
Nope, I can tell.
But what if it was a 12% out of something else or something, right?
No, I just meant if we're talking tests, you wouldn't
Overall.
get that.
Yes.
12%
Whoa, you're
sales
like,
tax.
whoa,
or
none of that, right? All right. So, is there anything in math class that you've done that has given you difficulty this year?
No.
Well, you seem pretty bright right there, and I'm glad that you are open to all of the different things that we are doing.
Yes.
So are you ready? We're going to give you a couple of problems left to do, but we're going to do it right after this.
Hello, I'm Aki Hoshide.
And I'm Megan MacArthur.
We're astronauts living and working aboard the International Space Station. Have you ever wondered how astronauts orient themselves in space when there is no feeling of up or down? In this episode, we'll discuss the vestibular system and the effects of free fall on our sense of direction up here on space station. Let's go try out some experiments with spatial orientation. The vestibular system is the sensory system our brains use to process movement using the perceived pull of gravity, structures in our inner ears, and through processing visual cues from our eyes. This information is necessary for balance, motion, and spatial orientation. The vestibular system is made up of several parts primarily located in the inner ears in a series of interconnected chambers called the labyrinth. The labyrinth has 3 semicircular canals, each oriented in a different plane to detect different movements.
In the micro-G environment here on the space station, the pull of gravity our body is accustomed to is different, and the vestibular system receives mixed messages. The semicircular canals sense head rotation in space, just as they do on Earth. Because the otolith organs rely on gravity to detect linear motion, they don't function the same way in micro-G as they do on Earth.
You've probably experienced similar mixed messages on Earth. Some people feel dizzy when they read a book in a moving car. The structures in your ear pick up on the motion of the car, but your eyes are fixed on the motionless book. These mixed messages can cause dizziness as your brain tries to determine if you're at rest or in motion. We call that dizzy feeling motion sickness.
Docking sequence is complete. Welcome to the International Space Station.
Endurance copies and docking complete. I'm happy to be here at the ISS.
This is similar to the way many first-time astronauts feel when they arrive on the space station. Up here, we call that space adaptation syndrome, or space motion sickness. This is a period where our bodies are adjusting and orienting to the new free-fall environment. One way we fight off space motion sickness is by reducing our body movements until we are acclimated. We also use labels, signs, and the design of the station to help orient ourselves. Lights are positioned up along what we call the overhead, and air intakes are positioned down towards what we call the deck. When we return to Earth, our bodies once again must adapt to perceived change in gravity.
Close your eyes and think about where you are right now. Can you determine which way is up with your eyes closed? What about down? Now, open your eyes and think about what signals you receive to help you determine direction. On Earth, we perceive up or down relative to gravity. While in orbit on station, we're essentially in free fall. There isn't a true up. Up could be anywhere.
Welcome to Which Way Are You Pointing?, where our astronauts try to figure out their orientation while they're in micro-G. They'll have eye masks on and earplugs in to remove those senses. On the space station, gravity has mostly been removed as well. They'll pick an object and see if they can point to it after being spun around. First, some terms you should know. Pitch is shown as an exaggerated nod. Roll is shown as you move your head from shoulder to shoulder. And yaw is shown as if you were shaking your head no. Let's play.
Target, ESA flag, rotation, pitch.
Oh, sorry, Mark. Let's try again.
Target, ESA flag, rotation, roll.
Wrong again, Mark. Okay, Shane, let's see how you do.
Target, laptop, rotation, roll.
There are just too many missing pieces of their vestibular systems to accurately orient themselves.
I encourage you to think about the way your vestibular system helps you respond to information from your environment, and take note of what's happening next time you feel a little off balance. Thanks for exploring the effects of micro-G on the vestibular system with us today. See you next time.
All right, more space stuff, huh? Pretty cool. All right, back over to the board. You're not done yet.
Okay.
All right. So pick a number between 10 and 99.
Well, wait, 10 and 99? Okay. 98.
98? Go ahead and write it on the board. So I want you to tell me which is larger or what's going on with it. 98% of 100 or 100% of 98.
100% out of 98 is big.
So
it's
we
big.
either have 98% of 100 or 100% of 98. Is one of those bigger? And if so, which one, or what's going on maybe?
It would be 100% over 98?
So you think 100% of 98 is bigger than 98% of 100? You and Cindy talk about it. I'll give you 1 minute.
So 98% of 100
So
Right.
basically, like,
means if there were 100 questions and you got a 98%, how many did you miss?
like 2.
So it still represents 98, yeah? Okay. Or 100% of 98. Which means how many questions would there be for you to get 100% out of 98?
It would have to be 100.
Well,
I mean,
100% is
98.
your score, right? Yeah, so there'd be 98 questions,
Yes.
and you got 100%, which would be, how many questions did you get correct then?
98.
Okay. So this one, we got 98, and that one, we got,
98, so they're equal.
There you go. That's what I wanted you to figure out, right? 98% of 100 is the same thing as 100% of 98. Do you see how those two work together?
Yes.
All right, come on over here, young lady. Do you know what an ambassador is?
Yes.
What's an ambassador?
Like somebody in charge.
Yeah, there you go. So come around this way a little bit, all right? We're going to take a look right there at Aaron, and that's the camera. So this is your uniform, and I'm going to move it up a little bit. We can't see anymore, though. But that is your ambassadorship uniform. Sound good? All right. Did you have fun today?
Yes.
Did you learn a little something?
Yes.
Excellent, even better all the way around. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.